Applications. How can we use similar figures to solve real-life problems? Using similar triangles and indirect measurement, we can find large distances and the heights of trees, flagpoles, and buildings. What is the difference between direct measurement and indirect measurement? When two figures are similar, you can use proportions to find unknown side lengths. Indirect measurement uses proportions to find measurements when direct measurement is not possible. Direct measurement is when an object can be directly measured, meaning that you can actually pick it up and measure the sides. How can we find the distance across the Grand Canyon? Maria is touring the Grand Canyon in Arizona and wants to determine the distance across it. Because the distance from one side of the canyon to the other is so great, direct measurement is not possible. She notices a huge boulder on the other side of the canyon and decides to use it as a landmark to construct a pair of similar triangles. Maria finds a point directly across the canyon from point A and places a marker in that location, labeling it point B. Then she turns 90 degrees counterclockwise and walks a distance of 1,000 meters along the same side of the canyon as marker B and places a marker at this new point C. So far, Maria has created one triangle. In order to use indirect measurement to calculate the distance across the canyon, Maria needs to create another triangle. From point C, Maria walks another 100 meters along the same line as markers B and C and places a marker at this new point D. Then, Maria turns 90 degrees counterclockwise and walks 2,500 meters and places a marker at this new point E. Maria is able to see points C and A are on the same line as point E. How can you prove that triangle ABC is similar to triangle EDC? How can you find the distance across the Grand Canyon? Angle DCE is congruent to angle BCA because these are vertical angles, and vertical angles are congruent. Angle CDE here is congruent to angle CBA here because all right angles are congruent to each other. Finally, we see that triangle ABC is similar to triangle EDC because of the angle-angle similarity theorem. There's two pairs of congruent angles, so these are similar triangles. Finally, how do you find AB? We write a statement of proportionality. All right, so let's see what that would look like. So we have AB over ED, so we have these lengths here, equals BC over DC. So AB is the length we're trying to find, but we can plug in numbers for all the other lengths. So ED is 2,500, BC is 1,000, and DC is 100. When you solve this, you get that the distance across the Grand Canyon is about 25,000 meters. How can we find the height of the Washington Monument when there are no shadows? We are going to use a mirror trick to find the height of the Washington Monument. This is another method of indirect measurement. Place a mirror with crosshairs, or an X, drawn on it, flat on the ground between yourself and the Washington Monument. Look into the mirror and walk to a point at which you see the top of the Washington Monument lining up with the mirror's crosshairs. The light rays from the top of the Washington Monument to the mirror and back up to your eye form equal angles. In physics, similar triangles can be used to track the angle and direction of light, especially when it's being reflected. The incident ray is the ray of light approaching the mirror. The reflected ray is the ray of light that leaves the mirror. The normal line is a line that can be drawn perpendicular to the surface of the mirror at the point of incidence where the ray strikes the mirror. This divides the angle between the incident ray and the reflected ray into two equal angles. The angle of incidence is the angle between the incident ray and the normal line, and the angle of reflection is the angle between the reflected ray and the normal line. Measure the distance from you to the mirror and the Washington Monument to the mirror. How can you prove that triangle ABC is similar to triangle DEF? How can you find the height of the Washington Monument? Here is a diagram of what we're dealing with here. So this is you. This is your feet, your eyes, your line of sight. Here's the mirror where you see the top of the Washington Monument. The reflected line goes up like this. So how can we use this and similar triangles to find the height? Angle CAB here is congruent to angle EAD here because the angle of incidence equals the angle of reflection. Angle ACB here is congruent to angle AED here because all right angles are congruent to each other. Finally, we see that triangle ABC is similar to triangle ADE because we have two pairs of congruent angles, and that is the AA similarity theorem. All right, now that we know that these are similar triangles, how do we find H? We write a statement of proportionality that uses H. So here we have BC over DE, BC over DE, so the height of the Washington Monument over the height of U equals AC over AE. AC, the distance from the mirror to the Washington Monument, over AE, the distance from U to the mirror. So when you plug in all the numbers, we get that the height of the Washington Monument is 555 feet.